Hi, my name's Dan Boniciolli and welcome to ChemSkills Podcast Suite. Uh, in this ever-growing series, I've selected chemistry skills and core concepts that I believe are essential for success in this subject. I've tried to present the information as succinctly as possible using examples and animations. Now, I'm always looking for new ideas and feedback, so please send me a message with your suggestions if you have any ideas. So let's begin the first podcast. Today, the topic of this podcast is balancing simple equations. Chemical equations are a symbolic representation of a chemical reaction. To balance a chemical equation means to ensure that there are the same type and number of atoms and charge appearing on both sides of the arrow. Now here's an example of a chemical equation. And in the equation you can see the compound methane reacting with oxygen to produce, the arrow means to produce, water and carbon dioxide. Now this equation is not balanced because you can see that there are 4 hydrogen atoms, for example, here on the left, but only 2 hydrogen atoms shown on the right. So the number of atoms are not equal, and consequently the equation is not balanced. And what we need to do to balance this equation is to begin with each atom from the left and work our way through to the right to ensure that we have the same number and type of each atom and same type and number of charge on both sides of the equation. So let's begin. If we start off with carbon, you can see the element carbon. There's 1 carbon atom on the left, 1 carbon atom on the right. So carbon is balanced. We move on to the next element, hydrogen. There are 4 hydrogens on the left. There are only 2 hydrogens on the right. So to balance hydrogen, we'll need 2 more hydrogens here on the right. Now, the way to do that is to put a number in front of the symbol, a coefficient. Now, we can only balance by adding coefficients. So something like this. Now, this would give us 2 lots of everything that follows that coefficient. So 2 lots of 2 hydrogens and 2 lots of oxygen. Because in 1 water molecule, there are 2 hydrogens and 1 oxygen. In 2 water molecules, there would be a total of 4 hydrogens and 2 oxygen. So the coefficient multiplies everything in the formula by that number. So now you can see that there are 4 hydrogens on the left, H4, and 2 lots of 2, 4 hydrogens on the right. So the hydrogens are now balanced. So we balance the carbons, we balance the hydrogens. Let's move on to the oxygen. Now, oxygen requires, there are 2 oxygens rather on the left, and there are 2 lots of 1. So there's 2 oxygens here in this water, and there are 2 lots of oxygen in the carbon dioxide. So there are actually 4 oxygens on the right and 2 oxygens on the left. We need another 2 oxygens here on the left. So to do that, we have to add a coefficient. So a coefficient like this, 2. So this has now doubled the number of oxygens. There were 2, there are now 4, and that balances with the number of oxygens on the right. Now, then in this example, the balancing process was reasonably simple. But just to summarize, in order to balance, we can only add coefficients. We can only add numbers in front of the symbols. We can't change the numbers within the symbols, because if we did that, that would alter the ratios of the atoms in that formula and in the compound, and it would mean that the identity of the compound changes. So there's no way that we could just decide that we would change the 2 here in water to 4 and make this H4O, because that's not water. So we're restricted to only changing the numbers in front of the formula, creating coefficients. Let's have a look at another example. In this example, we have a compound here on the left, which is called lead nitrate, reacting with sodium sulfate to produce lead sulfate and sodium nitrate. Now, when we look at the equation again, we can see that there are certain atoms that are not balanced. Yes, there's 1 lead on the left and 1 lead on the right, but within the brackets here and the 2 outside the brackets means that everything in the brackets has been multiplied by 2. So that means there are 2 nitrogens and 2 lots of 3, 6 oxygens on the left, but 2 nitrogens on the left, and then if we move over to the right, we can only find 1 nitrogen. So the number of nitrogens are not balanced. Okay, to balance this equation, yes, you can start from the left and work your way through to the right, picking each atom individually, but there's a shortcut I'd like to show you. But let's begin with lead, one lead, so the leads are balanced. Now we'd move into the brackets here. The next atom is nitrogen, and as I said earlier, there are 2 nitrogens. But what I prefer to do to speed things up a little bit is to balance this whole bundle of atoms, the NO3, which is called a nitrate group. And that will speed things up a little bit because the NO3 remains as a group over here on the right-hand side. So you can see that we've got 2 lots of NO3 on the left, but only 1 lot of NO3 on the right. And don't forget, we can only balance this by adding coefficients. So if there are 2 nitrates on the left, we'd need 2 nitrates on the right. So we achieve that by putting a coefficient of 2 in front of the whole of the sodium nitrate. Okay, moving on to the next atom, we come to sodium, and there are 2 sodiums, and by putting a 2 in front of the sodium nitrate on the right, we've also produced 2 sodiums on the right. And so that means the sodiums are already balanced. And the SO4 group, the sulfate group, stays as a sulfate group on the right. So we can balance that whole bundle, SO4, SO4, one of them, the equation is now balanced. We've balanced all the atoms. But notice in this example, we didn't have to go through and balance each individual atom because certain groups remained intact, like the nitrate and the sulfate. So that helped to speed things up a little bit. So just to summarize the rules at this point, the first rule is that you have to start from the left and work each atom through to the right of the equation, ensuring that the numbers of atoms on both sides and types of atoms on both sides of the equation are equal. Rule number 2, you can look for groups of atoms that have remained combined, and you can balance the groups, and that speeds things up for you. And number 3, it's probably also a good idea to first balance the atoms that are only found in one compound on each side of the equation, because if the atoms end up splitting into several compounds, it becomes quite difficult to balance each of those bits independently. So let's have a look here at an example of that. You can see that oxygen is present in 4 different groups in this equation. In this chemical, which is called ethanol, in oxygen, the element, in water, and in carbon dioxide. So oxygen's in 4 different places. So I wouldn't balance the oxygen first, and I'd leave the oxygen till last to balance. And quite likely that when all the other atoms are balanced, then more often than not, the final atom in the equation is balanced as well. But let's have a look. So let's begin. Rule number 1, start from the left, work your way through to the right. There are 2 carbons on the left, and there's only 1 carbon on the right. So we can balance this only by putting a number in front. We can't change the ratios of the atoms in that formula. So by putting a number in front, we'd have to put the number 2 in front of carbon dioxide. So now the carbons are balanced. We get to the next element, which is hydrogen, and there's 5 there and 1 there. So that's 6 hydrogens on the left. But over here on the right, there are 2 hydrogens. So 6 on the left, 2 on the right. We need to multiply this by 3 to get 6 hydrogens. So we can only do that by putting a 3 in front. Now, what that's done is it has also now changed the total number of oxygens on the right-hand side. And there's oxygens on the left-hand side that are in 2 different places. But we've already balanced all of the bits here in the ethanol. So to balance the oxygens on the right, it's probably a good idea just to manipulate this single element here on the left-hand side of the equation. So there were 3 and 4 oxygens, so 2 lots of 2, so that's 7 oxygens on the right. We won't count that oxygen, we'll leave that aside. But there are 3 here in total, so we need a total of 7. So if we put a 3 in front of this oxygen, that gives us 6 oxygens there, plus that oxygen in ethanol, which gives us a total of 7. And so by Leaving the oxygen till last, it's a lot easier to balance that equation. In our final example, this is an example of how charge needs to be balanced. Now you can see in this equation that there's one iron and one copper and one iron and one copper. So one would think that this equation is balanced. However, when you tally up the number of charges on the left, there are 2 positives and 2 positives on the left, so that gives us a total of 4 positives, but only 3 positives on the right. So the charge is not balanced. Now that's another thing that we have to balance when balancing equations. So to balance the charge, we need to put, again, coefficients in front of these terms in order to get the right amount of positives, or the same amount of positives, or if it were negatives, on both sides of the equation. So to achieve this, we can put a 2 in front of the iron components in the equation, which would now give us 2 lots of 2, that's 4, plus another 2 there, which makes 6 on the left, and 2 lots of 3, which makes 6 on the right. So now by doubling the number of ions, we've been able to also balance the charge. So in this situation, you would, just by trial and error, you would pick one of the elements, one of the things shown in the equation, change the coefficient, see the effect that has on the charge. If that doesn't work, go to the next number, try 3, try 4, try 5, try changing the number in front of copper until you get the same number of charges on both sides. Okay, well that brings me to the end of this podcast. I hope that was clear enough. Thank you for listening. If you have any suggestions or ideas for additional podcasts, or indeed any ways in which you think I can improve these podcasts, then please send me a message. So join me for future podcasts. Thank you. Bye.